Based on measured sensor data, allocation of well phase flow rates can be performed using virtual metering calculations. Any flow-related data can be used, but pressure and temperature sensors located downhole and up and downstream of the choke valve are most common. As an alternative, allocation curves can be used providing phase flows directly from a measured well pressure, assuming a fixed gas-to-oil ratio and water cut. In an online setting, the determined flow rates can be used for real-time production control of a field, using PNID control. The applications then send and receive data in a looped fashion, interpreting sensor signals, and determining controller set points from calculated flow rates and production targets. To enable virtual metering measured data from a field, installed sensors must be available. This can be done either through a data link to an external data acquisition system for online applications, or by importing historical data organized in Excel spreadsheets or predefined text file formats to a local database. To get data from Excel, open the workbook containing relevant sensor data. Use the import facility provided in the user interface and select the worksheet containing data to import. Having selected the range to import, data will be stored in a local database for use with calibration and tuning exercises, or offline virtual metering or allocation calculations. The principle behind virtual metering is simple. Measured sensor data is used as boundary conditions for steady-state flow calculations. A combined pressure and temperature measurement is used as point of reference, typically a downhole installed pressure gauge. These three plots are examples of measurements that can be used to estimate flow. Wellhead pressures, force probe measurements and differential pressure over the choke. A vector search algorithm is then applied using phase flows as free variables to minimize the difference between measured and calculated sensor responses. The following demonstrates the use of virtual metering on a data set with pressure and temperature sensor signals reflecting sharply varying flow rates, gas-to-oil ratios, and water cuts. All three phases, oil, water, and gas, are used as independent variables in a vector search to find the well phase flows. The red points depict reference oil rates, while the blue curve reflects the predicted oil flow from virtual metering calculations. The green curve is the associated GOR, while the purple curve is the predicted water cut. The depicted exercise is numerically challenging as there are very abrupt changes in system responses, and also, because all three phases, oil, water, and gas, are determined independently. The excellent fit between measured and calculated values demonstrates the robustness of the algorithm used. In some cases, it may not be possible to perform virtual metering for lack of data. To maintain system functionality, allocation curves can be used to substitute virtual metering. Using reference data with known flow rates and pressure, a polynomial curve can be fitted to the data providing an explicit relation between flow and observed pressure. This assumes a fixed GOR and water cut. To perform a curve fit, simply choose polynomial order and set the independent variable. The fitted curve can then be saved to file for use as an allocation, specifying a gas-to-oil ratio and water cut. To employ the allocation curve for a given well, simply open the file holding well data. Specify the pressure sensor which defines input to the curve and provide the allocation file name. Provision is made for turning the use of allocation curves on and off. When using allocation curves, these will override virtual metering calculations for selected wells. For best possible results, reference data from well tests can be used to calibrate and validate simulation models. To perform tuning, import reference data to a local database. Then use the data to find the model response giving best compliance with the measured field data. Multiple tuning parameters are available for adjusting model responses. These include phase densities, gas and liquid slip factors, heat loss factor and hydraulic roughness. The multipliers are adjusted to find the best possible match between measured and calculated system responses. The plots below depicts predicted oil and gas flow rates from a set of real sensor data. The two lower plots shows measured and calculated responses for wellhead temperature and pressure, resulting from a best fit to data. The virtual metering functionality is an element of integrated field operations and production optimization. The well flow data can be fed to a P&ID control module, which combined with production targets and constraints establish optimum control set points. Here we see the online sensor data for a well. The metered flow rates are calculated and shown in the top left corner. With an online connection to a data acquisition system, actual well phase flow rates are derived from primary sensor measurements. The plot shows virtually metered oil rates for 4 different wells, all producing to meet the field target oil rate. Forward prediction simulations, coupled to reservoir simulation models, can be spawned looking at effect of different optimization strategies. Transient processes can be started for determination of cool down times and startup consumption of hydrate inhibitors. All of this is accessible from a single application, allowing true integrated field operation and optimization, which can be performed remotely from actual field location.